Now let's talk a little bit about dependency injection. We've already seen that data binding decouples views and view models from each other, allows them to communicate without knowing explicitly about what's on the other end of the communication pipeline. Now we need something similar to decouple our view models from the client services. So far in the demos, you've seen where I'm hard coding the construction of a client service, our customer's repository, and I'm newing that up explicitly inside my view model and holding on to a reference to it. That's not such a bad thing if you don't care about unit testing, and if that's the only view model that's going to use that client service. But as soon as you want to start having some shared state in your client services that multiple view models see, and as soon as you want to write unit tests against your view model logic that uses that client service, you're going to have problems with the way we've been structuring things. So the solution is to use dependency injection and interfaces on our services. Those will provide the decoupling we need, and you'll see that we can easily wire things together using that. Now, when you talk dependency injection, the subject of containers usually comes up pretty quickly. You can do manual dependency injection, but that only gets you so far. Typically, you're going to want to use a container to help you out here. Inversion of control and dependency injection are two design patterns that are closely related. And a container is basically a chunk of infrastructure code that does both of those patterns for you. The IOC pattern is about delegating responsibility for construction, and the dependency injection pattern is about providing dependencies to an object that's already been constructed. So they can both be treated as a two-phase approach to constructing. When you use a container, the container takes several responsibilities. First off, it constructs an object when asked. So instead of newing up objects yourself, you'll go to the container and ask it to produce an object for you. As part of that process, the container will determine what that object depends on. And depending on the container you use, it can do that based on parameterized constructors, properties, or methods. To provide those dependencies, the container will then construct those dependencies, and will inject them into the object that's being constructed. But the dependencies being constructed may have dependencies of their own, and so on. So you have to recursively do this process until an entire object graph is built up from the object you asked for down through all of its dependencies. The container can also manage different instancing patterns and produce singleton objects where it constructs them on the first try and then just hands out a reference to them each other time some object takes a dependency on them. In terms of what container to use, there are many to choose from. There's Unity, Autofac, Ninject, Structure Map, and the list goes on and on. Most of these are open source projects that you can go and see have vibrant communities using them and good support from the open source project owners. So let's go take a look at how we can use dependency injection to break the coupling that we have between the view models and the client services at this point in our code.